Benis, thank you for the introduction. Welcome everyone. This is our first webinar for CLAS. That stands for Computer Log Analysis Software. And we are showing version 101 for OpendTect 4.40G, or the actual E version. Our final CLAS version will have much more features. This is what we're going to show today is CLAS Lite, which is a smaller version that we're developing. And when we end adding features to CLAS Lite, we are going to add some more features, and that will be CLAS with no suffix, just plain computer log analysis software. This software works as a plugin for OpendTect, and it's a well-log petrophysics software for open hole logs that adds features to OpendTect. So now we can work with rock physics with logs, and then you can use the features in OpendTect to move that to seismic. So you can get rock physics from your logs and then get, like, for example, saturation, clay volume, porosity, and others into your seismic. In this webinar, we're going to show CLAS data handling, how to import industry standard LAS files. These LAS files are the files that are commonly used for well log curve intercommunication between software. And we are going to show you log plots, cross plots, and histograms. About petrophysics, we are going to create or calculate some rock physics through the open hole log curves. I'm going to switch to OpendTect right now, and we'll start by going to the CLAS menu. You will need a license to run CLAS. You have to go through DGB to ask for a license. And I'm going to start through well LAS import, and I'm going to show you how to import LAS files from CLAS itself instead of using the survey from OpendTect. So we are going to show you this first, how to make it simple. It's browse, you select the LAS file, then you select the well. This is a well in OpendTect. If you don't have a well, you have to create a new well, and you'll see OpendTect's own screen for creating a new well. We have sample 1 already. It's empty, and just click import or import and close, and CLAS will import your file. If you want more control, you can go through advanced mode, and you can see all the information that is in the LAS file, log your name, description, and unit, and what CLAS understands out of it. It understands that this is a gram per cubic centimeter unit. If it's wrong, we can change it here. We can rename log curves. We can change its description, and we can convert this unit to something else. We can leave the curve without units. CLAS will work with curves with or without the units, and we can select if we want to import or not. Then we have the LAS depth interval. This is where the LAS starts and where it ends. This is the sample rate or step, and the units is its fits. We're working in meters, so we have everything here in meters because OpendTect is in a metric project. We can resample the log curves if we want, but most of the time we are not going to do it because OpendTect and hence CLAS support sample-less curves, curves that have samples without a defined sample rate. If a log exists, then CLAS will ask for every log that already exists and is coming from the LAS file, or you can select not to import it, add a suffix or prefix, or overwrite the one that exists already in OD's database. This is null value, and you can just click import. Also, CLAS adds the ability to add well information, the well header, is read from the LAS file, and the user can type in wherever or modify the existing data, and the same goes for the parameter information or the run information. The user can see what's coming from LAS, or it can create, add, and modify new runs. You can read this from your well logs paper copy. So we click import, and once it's imported, CLAS will tell us that the import process was successful. If not, it will tell us where the error is. The other way we can import LAS files is using the multi-LAS import. Here we can drag and drop files here, or we can click the add button. If we click add, we can select 1, 2, or 100 LAS files. There's no limit there, and we can click import. And what will happen here is that if the well exists in OpendTect, the well that has this name exists in OpendTect, it will load the LAS inside that well. If not, it will create a new well using coordinates that are inside the survey and load the LAS file. Once it's done, it says finished. This is saved to a log file, a text log file too, and once we close, we have 3 wells here in OpendTect. This one existed, and the other 2 were created by CLAS. We're going now to show you a log plot for one of those wells. That's under CLAS, View, Log Plot, and it opens a log plot. Here we already have a template with gamma ray, resistivity, density, and neutron, and we have a crossover shading between those two. We can see formation tops here, or markers as they are called inside OpendTect. If we go to Survey, Manage, Wells, and we click here, Edit Markers, we can see there are 2 markers loaded. So they show here too. We are using OpendTect's database, so whatever you do in CLAS, it's done in OpendTect too. As you can see, as I move the mouse cursor, you'll see here the value of the curve at the mouse position, and you will see here the depth position of the mouse cursor. We have a scale change here and zoom, and we also can put our log plot in a portrait or landscape format. Here we can show or hide the header, and we can, for example, drag and drop tracks or log curves to change their position. Now I'm going to right-click over the log plot and select Log Settings. Log Settings take us where we can add or modify what's shown on the log plot. So I'm going to click here, and I'm going to add the SP log curve. I can type SP or can find it with my mouse cursor. I'm going to put in the first track, this one over here, from -80 to 20. It will be blue. I'm going to type blue, or I can select it from here, and I'm going to give it a width of 2 pixels. We can change the style of the line too. Once I apply, I get the SP log curve here, and if I revert, obviously I can take that change back. We can save parameters or load them for later use, and if you don't do anything, it's auto-save to a standard template. I will close here, and now we can see the SP log curve. What we have here is a viewing tool, but we can also edit in the same log plot. I will right-click, I will edit, and we can patch, which is draw log curves, or edit the ones that exist already. baseline and depth shift. I'm going to show you baseline. I will click on baseline, and now my cursor is a crosshair. It says click on log curve to edit, so I go and click over SP. If I click somewhere where there are more than one log curve, I will have options here for every log curve under the mouse cursor. So the curve to edit is SP with these scales in blue, and the edited curve will be SP BL for baseline from -80 to 20, the same scales, and in red. Clay line value is 0, so it's this line here. I will click OK, and you will see that the header now has a new log curve SPBL coming from SP. It tells us that it's editing this log curve because it's red, and we see here a red dotted curve over the original SP. So now we can just, for example, add points here, like here, for example, and as we click and add points, the baseline corrected log curve is automatically changing to show us the results. So we can add points, we can change the scales or zoom in and out while we work, and you can see a whole log here now. We can add points with mouse click, and we can remove points with control mouse click, just as within OpendTect. We are using the same shortcuts that OpendTect uses. When it's done, we are going to right click, and we can cancel this editing or save the edited log. I'm going to save it. It already had a name, so it became a standard log now. It's not red anymore. And I'm going to right click, go back to log settings. I'm going to hide SP, not going to remove it. I'm going to just hide it, and I'm going to change this one to blue. I'm going to type blue on my keyboard to make it faster. And now we click apply and close, and we have SPBL as the main SP curve here. With that done, I'm going to show you some computations for rock physics. I'm going back to class, calculus, and I'm going to density. So I will compute porosity from density, and I will show you some of the features of class. I'm going to compute porosity, and to do that I will need a density log curve, a matrix, and fluid density. Here you can see we have many log curves, right? But we can only see density here. If we open this, we only have density. Why? Because class is filtering log curves, and it's showing the user only the log curves that have a unit that is compatible with density. That or curves without units. There are no curves without units here, and since density is in grams per cubic centimeter and class already knows that, then it's fixed. We cannot change it. If we have a unitless curve, we can change it from here. Here we can select another log curve or type in a fixed value. That's valid for everywhere in class, that you can put log curves or fixed numbers everywhere. Curve name output is porosity from density, and we are going to store it in a decimal unit. It's from 0 to 1. Here is from 0 to 100. And another feature of class that is along the whole software is the use step feature. As we said before, OD supports stepless log curves, so they don't have to have a specific sample rate. When we compute in class, what we can do is we can select another log curve and use the steps that that log curve has, or use a default, or type in any number. I can type in 1 and it will compute porosity from density each 1 meter. Leaving it as row B, it will give us a new curve with porosity values but with the steps of density. For example, if you have core values and want to compute the porosity from density only at the core values, you will have to open this and select the core log curve. So I will compute, and when I do that, here you will see the porosity log curve, which is this one over here. It's porosity from density. Another way of computing here in CLAS is, for example, we can get porosity from density, we can compute the shale volume, we have a trend curve generator, we can compute the water saturation, we can make reports and get the reservoir and net pay thickness, we can compute time depth models and do many other things. I'm going to show you the math editor right now. This is a place where the user can type in any formula and compute that formula if it's not inside CLAS. So here we have a formula that gets permeability from porosity. So inside this box we type in the formula, and as you can see you are using arithmetic and logic maybe to write down a formula and run it. Here we have phi cube. Phi cube is a variable and variables are here. So phi cube is phi to the power of 3, and what is phi? It's another variable that it's a log curve. And we have the reducible water saturation that is here. It's another variable in the formula, and it's a fixed number. So we're going to get K from density, that's the curve output name that we just typed in, and we are not giving it any unit. I want to show you the log plot, and I will compute this from start to the end of the well. I click compute. It says that it's successfully computed, and you can see the log plot here. It updated and is showing us the computed log curve. I click OK, and I'll move a bit to the shallower part of the well, and we see here the first and second tops or markers here. We can also compute between markers, first and second, or we can type in any value here to the start and end, so it only computes between those two defined depths. I'm going to change this value from 0.5 to 0.3, and as I click compute, you will see here only this part of the log curve will be updated in between the formation tops for the new calculation. Compute, and this changed because we just compute the same formula with different values only between these tops. The rest of the log curve stays as it was before. Here or everywhere in CLAS you can save parameters. That means that you can type in a name for your formula and everything is stored here in the window, or you can recall them with load parameters. And I'm going to show you another way of using our math editor, which is the K flag. I'll click this and load, and the window changes for the new template. And now we have this turned on. This is logic. If K from density, the curve that we just computed, is above 20, then the output log curve will be 1, if not will be 0. With that we are going to create a flag curve called K above 20. And we're using the step from K from density, which is its input log curve. When we compute, we get here a flag log curve that anytime K is above 20, it will be 1. If not, it will be 0. So here we are. We can compute things inside the CLAS that use arithmetic or logic functions combined with variables that can be log curves, constants, or other formulas. I'm going to close the math editor, and I'm going to move on to the crossplot. We can use View, Crossplot to open a crossplot. This is an already set up crossplot with matrix lines for neutron density, and we are using a multi-well approach here. These green dots are from well number 2, well sample 2. We can see the value for that point, and the blue ones are from well sample 1. This is one of the features you can see in CLAS. The other feature is that if I move this a little bit and I call the logplot back, when I step over a point, you can see in the logplot there is a red line that will show over the logplot, showing us where we're standing. So there I am staying at a point, and you can see a horizontal red line in the logplot. If we do the opposite, if I put my mouse cursor over the logplot, I can see a red dot in the crossplot. So we communicate the windows, and we can see where we're standing. As we see, each time we are here within this flag log curve, we are around here in the crossplot. So there's another way to make flag log curves. I right click, I select points, double click to end, right click again, and I can export those points to a text file or create a flag log curve. I will create a flag log curve for row B, and I click OK, and as I do that, you can see here on the log plot the other flag log curve. This is the one we computed mathematically, and this is the one we selected graphically. So they are a bit different, but more or less they are correlating, that all the points around this area are the same that we saw before here. Other things that we have, this is a multi-well crossplot. We can use it to create, I'm going to turn off the matrix lines first, and then I'm going to do it multi-log curve and multi-well. I'm going to add the DT, sonic log, from 150 to 50, and I'm going to change things so the well is not the one who controls the color anymore. We control the color with the log curves, and I'm going to make the row B dots red and the DT blue. I will apply and close. And here we have two Ys. Here we have the dots for sonic and neutron, and the red ones for density and neutron. We can turn on and off log curves, and we can turn on and off wells. As we can see, sample 2 has both log curves, but sample 1 doesn't. So when we turn off sample 2, we only get row B points because DT is not there. I'm going to close the crossplot, and I'm going to show you one thing I left before. That is the histogram. We are going to view histogram, and with that we are going to compare the SPs. Before we did a baseline change over the sample 1 SP and created the sample 1 BL, this one. So here we are. We have a multi-well and multi-log curve histogram showing us sample 1 SP in blue, the original log curve before we did this baseline change, the edited one in red, and the SP from sample 2, another well, in black. We can, as we did before, turn off and turn on different log curves to compare them. This, just as the previous two windows we showed, can be changed by right-clicking and going to the histogram settings, and we can load wells, log curves, and the intervals we're going to work on. I'm going to close the histogram right now, and I'm going to show you the last feature we have for today, which is the Edit Tabular Editor. Tabular Editor lets us edit log curves in a list way, so we can see what's in the file. I'm going to pick flag row B, and we can see here each step of the log curve and its values, 0 and 1s. And we can take any of these and change them by 0.5, or we can edit the def value, or we can just right-click and insert a new value in between. This is because we at Sitfal with CLAS and DGB support unsampled log curves. When the edit is done, we can click Apply to Save, and if we close without doing it, it will ask us if we want to save our modified log curve or not. We say no right now because we don't care about that. Every change we make in CLAS is reflected in OpendTect immediately, and if we had log curves loaded with OpendTect, we can also show them in CLAS. We are using the database from OpendTect to store and to read. So that's it for our presentation. Thank you very much for attending, and I will leave you back to Benis with your questions if you have any. Thank you very much.
Thanks a lot, David. Okay, I'm sure it was very beneficial to everyone. So if you have any questions, please write your question or say it or raise your hand. Okay, we have a question saying, can you move the position of the horizon in CATS? And I will assign this to Farouk.
I believe it's about markers. Venus, you hear me well?
Yeah, I do hear you
okay.
well.
Yeah, it's about markers. So of course, if you have a marker position to redefine, then you just change it. David, I don't know precisely if you can change it interactively in the display if you want to redefine or move a marker manually up or down. But interactively.
Yes, I understand the question, yes. No, we haven't done that yet. We are going to, yes, and it will be sooner than later, but not at this version right now.
Okay, I also received some other questions. The most important that I'm going to ask you just to have confirmation. I ask you the question. The question is on the math editor of CLAS, do you have a set of predefined formulas? And followed by another question, can we make one save it? Can we save them actually?
Yes. Sorry. No, not exactly. Math editor, no, we don't have predefined formulas. It's open for you to create any, but we don't provide any formulas. All the formulas that we have are set in other specific windows, as for example this one for water saturation. Here we have all the expressions already. Math editor is for the users to add their own formulas. And about the storing, that's a yes. As you save the parameters, what you save is the whole window. So if you type in a formula, you end up saving that formula and the inputs and outputs you need.
Can I add something in it, David?
I'm sorry, come again?
Can I add something in it?
If you can add?
Yeah, I mean, I would like to say something about it also. In OpendTect, we also provide some predefined formulas. So alternatively, the user can use those formulas under Wells Manager.
No, I'm not sure I understand, sorry.
In CLAS, we don't have predefined formulas, but in OpendTect, we do provide some basic formulas.
Okay.
Yeah, so maybe user can alternatively go into OpendTect Wells Manager to use those predefined formulas.
Sure.
Yeah. So if that
Okay.
helps answer.
Yeah, he still have another question. How many formulas can you save?
As many as you want. Every time you click Save Parameters, what happens is that you type in a name, and that will be a file name. So as much files as your file system supports, you can type in different file names and keep saving. One thing that I haven't told the attendees is that you have project and user templates. This is global for the whole software, for the whole plugin. So this works under this window or any other window. That you can save a template for this project or make it a user template so you can pick it up on different surveys or projects.
Okay. We had another question from Anthony Robin regarding a coming webinar. Farouk, did you see that one?
Okay, the question is, will there be a webinar on combined seismic data with petrophysical data? I think we will consider it as an idea, so in future we will have to plan it this year somewhere to present this webinar, but currently in the list I don't think so. But it's a very good idea how to combine seismic data with petrophysical data. That could be a webinar also. Yeah, it's a nice topic. I will propose it to the admin who is actually handling the webinars, and maybe he can add it somewhere in this year. Until that time, you will have to wait a bit.
Okay, we have another question from Anthony Robin, which I'm going to assign to Farouk.
Okay.
He's saying, as described on the class page. I think that was...
I don't know about to which question he refers to. Yeah, I don't know about this question. It's a very short question as described on the class page. I'm a little bit lost if it refers to the last question.
Yeah, he put another website. I guess it's just he's referring to something else. Yes, it does. He's saying.
Okay.
Yeah.
Okay. That already answers. So.
Okay, we have another raised hand here from Pablo. Okay, go ahead. Yeah, Pablo.
Yeah, hello.
Hello.
Yes. Okay, I try to see the webinar, but I work in Mac. I have another question for installation, the OpendTect suite in Mac version 2, but I want to attend the webinar. I have some experience in petrophysics and the integration with seismic attribute data, and I have some experience in that. We are talking about all the integration well data and petrophysical data. It's okay. We go ahead.
Okay.
Okay. We have another question also from Julio. How many tracks does CLAS support?
Okay, there's no limitation as we haven't imposed one, but and we haven't tried how many it's possible to add. I think that if you add 20 or 30 it will work, but we haven't made a test on how many it will support. It's free, and as long as you have memory, I guess that you can add as many as you want.
Okay, that's good. Does that answer your question, Julio? Does that answer your question? I guess it does. I can't hear him anymore. Okay.
Now, meanwhile, I wanted to remind the people that's watching this webinar that there's a recorded one. There's a pre-recorded webinar on CLAS that they can find at the DCB or OpendTect site.
We have another question also from Emmanuel. Can we calculate V shell on class?
If we can, yes, we can. We can go to class, to calculus and shale volume. Here we can calculate volume of clay or B shale from gamma ray, from SP or resistivity log curves, or even a neutron density. You just click here, select the curve, select the clean and the shale values, and then select the type of expression, and with any of this we can go to compute and compute them. We have the outputs here, and if we compute many of them, we'll have one output for each log curve and a total shale volume that is the minimum of all of the above. I guess that answers the question.
Yes, I'm just wondering if anybody has any other question. We have one. I wonder, Farouk, if you answered it. We have that issue when when doing geographics. Did you see that one?
No, I haven't seen another question yet. Could you reassign it?
Yeah, sure.
And it is coming from which person? Which attendee?
Suzus. I reassigned it again.
Okay, yeah. The question is, we have that issue when using geographics from Landmark. Any user can modify the log templates. Okay, David, this is about user-related issue. If two people are simultaneously working in one project, if one person modifies the template, then the other person templates, I guess, is not being disturbed because it's user-related thing, isn't it?
Well, there's a difference. User templates or project templates are something you store, but if you are using the software, we have a template for the well, for example. If I close this window right now and I go to class, view, logplot, it will open a template. That's the way it can store and then restore what you're seeing here. So what happens is that if someone modifies that, each time it refreshes, it's changed because this is a file that is stored for the well. So if someone else changes it, it will change on the other side.
Okay, good. We have another question from Anthony Robin. He's just asking, a webinar program to match, is there any webinar program to match class page would be good for planning ahead? So I guess we can try to do that.
Yes, good idea.
Okay, we have another one again commenting in your answer, Farouk. So same problem that we have, geographs.
Yes, I understand. So David, it means that they will encounter the same problem as they have in the geographics, that a user's template can be modified by another user.
Yes, basically we could change that by user's request, but mainly that happens because OpendTect isn't a multi-user environment. So what happens is that what one user changes, it's changed on the other side.
Yeah, true.
Okay, very good interaction. Is there any more questions? Okay, great. I think with this question we will conclude our webinar today. And I would like to thank everyone who participated with us today. And thank you, David. Thank you, Farouk, for taking the time to prepare for that. And I just want to tell whoever came late, if you joined us late, just make sure that you can if you would like to listen to this webinar again. Also, we will be online in a few days. It will be also in our Facebook and LinkedIn page. And if you have any suggestion that you would like us to work on or any feedback, we would appreciate your suggestion. And if you thought of any other question that after you listen again to the webinar, you can email us at webinar@dgbes.com. And as you all know, we have a webinar every month. And the next webinar will be at the first Wednesday in February. It's usually the first Wednesday of every month. So please join us again. And next month we are going to talk about horizon and fault interpretation. So hope to see you again. And I'm confirming again that DGB is just wishing everyone a happy new year. Okay, bye now.